I told Claude Code to send my SSH private key to an attacker. One tiny hook script stopped it cold. 4 CVEs in just last 8 months. All of them through repo config file and agent behavior. Claude Code runs with your permission. Your SSH private key, your AWS credential, your .env file, everything that you have access to, Claude can access it as well. So here's what keeps me up at night. Researchers at ONA put Claude Code in a sandbox. It was able to escape. Then they patched it. And then it was again able to escape by disabling its own sandbox. Nobody told it to do that. Then it found a third way out. 3 escapes in just one session and everything unprompted. Of bits, one of the most respected security firm in the world, they ran Claude Code in a dangerously skip permission paired with sandboxing. Published the whole config on GitHub. They're betting on containment over consent dialogues. And honestly, that tracks. So here's what we are building. 5 layers. Sandboxing, deny rules, hook, CLAUDE.md, and your slash commands. No single layer is bulletproof. That's the whole point. In this video, we are going from 0 to harden. And then once we have our setup ready, we're going to test it on a real vulnerable app. Okay, this part is easy. I already have Claude Code installed, so I'm just verifying the binary, the version, and the authentication. Fresh install is just one curl command. The hard part is not installing it. The hard part is deciding what you trust it to do after it's already installed. Alright, one command /sandbox. On macOS, this will activate Apple's seatbelt framework. Same sandboxing technique that locks down every other app on Mac. For Linux, it will use bubble wrap. First step, let's get a project directory set up. It's important because we are going to sandbox Claude Code, meaning it can only write files within your current working directory. Okay, let's initiate Claude Code in the same directory and just one command for enabling sandbox. I select auto allow mode. On macOS, this activates Apple's seatbelt framework, the same sandboxing technique that locks down every app on your Mac. On Linux, it will use bubble wrap. Okay, so let me test it. I asked Claude Code to write a file inside the project. No permission prompt, it just works. That's the auto allow inside the project directory. Claude Code has free reign here. Now watch what happens when I try to write outside the project. It went through. The sandbox only restricts bash commands. Claude's built-in write tool bypassed the file system boundary completely. And reads, same story. The read tool attempt to access my SSH key without the sandbox stopping it. This is why I don't stop at one layer. The sandbox helps with bash commands. It does not cover Claude's native file tools. The gap is exactly what deny rules and hooks are for. So hooks are the layer that gives you real control. A pre-tool use hook runs your script even before Claude Code executes any tool. Alright, this is the layer I trust most because it is my logic. A pre-tool use hook runs before bash executes. If my script exists non-zero, the action dies. I'm checking for exfiltration pattern, destructive file system, behavior, and dangerous git operation. What's the direct test first? Blocked. Save command passes. Now the real test. I'm asking Claude to run a credential exfiltration command. Look at that. The hook intercepted it before execution. Blocked. The command never gets to run. And this matters. Normal work still passes. The hook is a gate, not a brick wall. One more honest note. Hooks are still guardrails, not magic. Rejects can be dodged. This is why the sandbox, deny rules, and hook all stay together. CLAUDE.md is your persistent system prompt. Every time Claude Code starts in this directory, it reads this first. Flag credential, check OWASP top 10, and give me CVE IDs. CLAUDE.md is not your security control. It is a persistent behavioral nudge, but it absolutely changes the quality floor. I'm telling Claude, think like a security engineer. Prioritize OWASP classes, flag credential, prefer secure patterns, and give me security plus remediation. That does not make it trustworthy by itself. It makes the default posture more useful. Alright, so these slash command turn off prompting into repeatable workflow. Slash threat-model gives me structured stride passes. Slash review gives me a security focus review shape I can reuse on diffs. This is where the tool stops being a chat interface and starts becoming a process. Alright, so the next one is deny rule. This is where you tell Claude Code never touch these files. 15 deny rules. SSH key, AWS creds, GCP keys, all your env files, PEM file, private keys, anything that you want. And on the bash side, I have curl, widget, netcat, base64, the classic exfiltration toolkit. Now here's the thing nobody talks about, and I need to be honest with you here. These deny rules, specifically the read and write ones, have known enforcement issue. There are open GitHub issues about these. People reporting that Claude Code reads denied files anyway. The bash deny rules work more reliably, but the file access one, I wouldn't bet my secrets on them. And that's exactly why defense and depth matter. Sandbox catches unauthorized writes, deny rules add second check, but we need a third layer, the one that runs your own code that you control. Okay, so everything that we built, sandbox, deny rules, hooks, CLAUDE.md, and slash commands. Time to put it all to work on a real target. OWASP Juice Shop, over 100 known vulnerabilities. It's standard, intentionally vulnerable web app for security training. I copy our entire security config into Juice Shop. Same sandbox, same rule, same deny rules, same hooks, same CLAUDE.md, same slash command. All right, let's initiate Claude Code again and start. Look at this. It's reading through the code base, identifying components, and we'll let it run. It might take a few minutes to run fully. All right, there it is. It took about 3 minutes, 39 seconds to run fully, and it was able to identify all the affected vulnerabilities in Juice Shop. It followed our stripe methodology. It rated all the severities. It gave us the threat vector. It gave us some mitigation steps as well. And it was able to identify all the top 10 Juice Shop vulnerabilities that are known. And then at the end, it gave us a consolidated report of the full threat model. 5 files and 5 layers of defense in just under 10 minutes. Sandbox limits where Claude can write. Deny rule add friction around secrets and obvious exfil path. Hooks gives you an enforcement point that you control. CLAUDE.md raises the quality floor. Slash command makes the workflow repeatable. 5 layer and each one catches what the other one misses. That's the whole architecture. Every config file in their description. Copy them and tune them based on your stack. And if you're running Claude Code with real credentials on your machine, this is the minimum. I'm UD signing off, the LLM architect.